Hi, you guys. Welcome to skill or lesson 7 on solving rational equations. So remember that rational equations are anytime we have a polynomial over a polynomial or something that looks like a fraction. So we've done adding, subtracting, dividing, and multiplying. Today we're going to talk about solving. So it's kind of an intro to rational expressions. If I told you 1/2 plus how many other halves get me 4 halves, you would tell me I need 3 halves or just 3. So basically how you're thinking of it or how we can think of it is if the denominators are the same, we can cross them off and then just solve for the numerator, just solve the numerator. So now we ask ourselves, what do we do if the denominators are not the same? We need to get everything to have a least common denominator and then can solve the numerator. So I'm going to look at this. My denominators are not the same. So let's think about what I can multiply everything by to get the least common denominator. 2, 4, and 4. Everything needs to be a 4. So this is going to get multiplied by 2. So this becomes 2 over 4 plus x over 4 equals 5 over 4. Then I can cross off my denominator. And it becomes 2 plus, oh, not 2x, 2 plus x equals 5. And I end up with x equals 3. So if we look at this one down here, it may appear like this is not a fraction, but I can write that over 1. So really, I need everything to have a 3 on the bottom. So I can multiply this by 3 over 3. If you think of this another way, that's fine. That cancels out. I now have x equals 12. You could thought of it as x over 3, and then that cancels out. I end up with x equals 12. So this is how we handle it when the denominators are not the same. We make the denominators the same. So this is similar to the last problem where not everything is the denominators are not the same. So I can go ahead and rewrite this. I'm going to put that negative up with the 3. And I'm going to write that negative 5 over a 1. So I need the denominators to be the same. So the greatest thing a u and a 1 go into is the smallest thing that both u and 1 go into is 1u. So this already has a 1 and a u. This just needs a u over u. So what this ends up looking like is 3 over u equals negative 5u over u. I want you guys to see if from here you can cross off the denominator and solve the numerator. So pause and go ahead and cross off the denominator and solve the numerator. Okay, we should have crossed off the denominator. Going to divide both sides by negative 5. 3/5 equal u. So that's what we should have gotten for this one. So remember, we're taking our notes. We have our slide problems down here. Okay, if we remember how to solve rational expressions and excluded values, remember excluded values are values that cause us to divide by 0. So you want to be taking these notes. If this answer we get when we solve is the same as the excluded value, it is not a solution. Let's check the problem we just did. So I'm going to go back to the problem we just did. What would have caused this to divide by a 0? The excluded value was u equals 0. The actual value was 3/5. So if you want to write this in your notes somewhere, we can write excluded value was y equals 0. the solution was u equals 3/5. Those are not, u can equal 3/5 because it won't cause us to divide by 0. Okay, this is another example where the denominators are not the same, so I can think of that as over 1. I need both of the denominators to be a u over 2. So go ahead, pause your screen, see if you can solve it from here. So you're pausing your screen, see if you can solve it from here. So we should have gotten u equals, we divide both sides by 6. But we need to make sure that doesn't contradict our excluded value. So our excluded value, if I set u minus 2 equal to 0, it would be u equals 2. So our excluded value is u equal 2, but that is not the same as 15 divided by 6. Therefore, 15 divided by 6 is a fair value and is our answer. Okay, so we do not have common denominators once again. We have a u plus 7, a u plus 7, and a 1. So I want you guys to pause the screen and go ahead and write these as something with a common denominator. So you're pausing the screen and figuring out what the common denominator is. Okay, so we should get that u plus 7 is the common denominator. So this 5 over 1 needs a u plus 7 over u plus 7. And then once we have that, we can cross the denominators out and solve the numerators. So I get 2 equals 7 plus 5u plus 35. So 2 equals 7 plus, or not 7, 42 plus 5u. And then I get negative 40 equals 5u, divide by 5, divide by 5. You end up with u equals negative 8. Now we want to take a second to see if that's what my excluded values are. I'm going to start using EV as excluded values. So my excluded value happens when u plus 7 equals 0. So I'd subtract 7 from. So u minus 7 is my excluded value, and that does not contradict my actual solution. So u minus 8 is a good actual solution. Okay, so we may need to factor to find the least common denominator or solve the numerator. So you're keeping going back to this factor chart that we've been looking at for the last few lessons. When factoring first, look for the greatest common factor. And then these are the 3 options we can do regarding how many terms we have. So let's look at this one. We do not have common denominators. We're going to say that that's x over 1. So I want you guys to take a second and think through, what does my common denominator need to be for all of these? Let's go ahead and think of what your least common denominator needs to be. we should see that everything at least needs to have an x. So I'm going to multiply this first one by x over x, that fancy 1. And then once I have all the same denominators, cross them out and solve my numerators. So x squared minus 7 equals 2. There's a couple ways to think of this. If you added 2 to both sides, that's fine. I'm going to show us, or subtract, if you added the 7 to both sides, that's fine. I'm going to show us doing it away with factoring just so we get more practice with factoring. X squared minus 9 equals 0. So based on the chart that we just did, this is difference of squares. So this becomes x plus 3, x minus 3 equals 0. If I set each of these equal to 0, then I'm able to solve for x. So that's one of my options. So x equals plus or minus 3. I still need to do my excluded value. Would just be when x equals 0. So remember, EV just means my excluded value. My excluded value does not contradict what I have down here. Okay, so we still have this idea that we don't have least common denominators, so we need to make one. So I hope you guys see this idea is reoccurring. I just need to make common denominators, remove the denominators, and solve the numerator. So here's my least common, these are all my denominators. I want you to pause the screen and make them all have the same denominator. So what we will see is that my least common denominator is a u minus 1 and a u plus 7. So this needs a u minus 1 over a u minus 1. This one needs both. So it needs a u minus 1, a u minus 1, as well as a u plus 7. That looks messy. We'll clean it up here in a second. Then you can cross out the denominator. So we end up with a u plus 7 times 4 times u minus 1 minus 3 u minus 1 equals negative 7. Now from here, this is just tedious and taking the time to solve it. I'm going to multiply or FOIL these two. That's what you end up with, and I'll distribute the 4, so 4u squared. So this is just tedious at this point. I'm going to combine like terms. Add that 7 to the other side. This is great so far, but I'm not done because I have not solved for you. So this is where your different factoring options come into play. So I need to, here's my ACB tree. Here's my A, B, and C. Here's my A times C is, I'm going to get us a negative 72, but adds to a B of 21. So I have 24 and 3. That 3 needs to be the negative 1. So that way it adds to 21. So this is going to be negative 3 plus, there we go. Well, that looks better. So I can pull a u out of this. I can pull a 6 out of this. Ultimately end up with u plus 6 and 4u minus 3 equals 0. Sorry, we're all over the place with this one. So we end up with, now I need to set each of these equal to 0 to solve for them. When I do the u plus 6 equaling 0, I should get a u of a negative 6. For u minus 3 equaling 0. Those are my potential options, but I need to think through my excluded values. Are x equals, or u equals, sorry, we're still dealing with u's. So I would set u plus 7 equal to 0 and u minus 1 equal to 0. So when u equals negative 7 and when u equals 1, those would cause us to divide by 0. However, both of these are safe and they don't cause us to divide by 0. We only got a few more problems left. Doing great. So this idea that we still need to factor, so please keep coming back to this tree. Remember, the first thing that we want to do is find the greatest common factor. So we do not have a least common denominators, but so we want to try to factor our denominators to see in order to find the least common denominator. So I'll help us walk through this one. I'm going to move that negative to the top. I can pull out a 4. I end up with y minus 6 plus this 1. Put that negative 8 in the numerator. So now I have a better idea that my least common denominator is a 4 and a y minus 6. So I need to make sure that all my factors have that. This needs a 4 over 4. This needs both of those. 4y minus 6. Once we cross off our denominator, because everyone has a 4y minus 6, we end up with negative 3 plus 4. Negative 32. So now this is just a solving game of combining like terms. So I want you guys to try to stop and solve this on your own and see if it affects your excluded value. So I got negative 4/5 for my y. Now I need to think of my excluded value. Y equals something. I would see that I have y minus 6 equals 0 if I look at my common denominator. Which tells me y cannot equal 6, so my excluded value is y equals 6. Okay, this is the last big factoring one we're going to do. So I want you guys on your own to try to find the common denominator. So you want to find the least common denominator on your own. Just go ahead and identify what that is. Once you find that, repause and I'll show you how I did it. Okay, so we have A, B, C. I know I need to factor that. I know everything at least needs an x minus 4, or u minus 4, into u minus 2. So A times B is 8. A times C is 8 multiplied to my, or add to my B of -6. So I'm going to do -4 and -2. And that will replace U squared minus. And then I'm just doing my factoring by grouping. My factors that I end up with are U minus 2, U minus 4, which is what that should be. So I have an 8, U minus 2, U minus 4. I'm just rewriting this. We'll figure out what everyone's missing in a second. Okay, so my first factor at least needs a U minus 2. My next factor is missing the U minus 4. Remember, once our denominators are the same, we can cross off the denominators and solve for the numerators. Okay, I think I want you guys to pause, solve the rest of this on your own, including your excluded values. I will show my work, but I want you guys to try it on your own first. I just distribute the 1, distribute the 5, and then I combine like terms. So minus 22. Oh no. From here, we end up with a 5 equals U, but I need to take a second to find my excluded value is when U equals what? So U minus 4 cannot equal 0. So one of my excluded value is 4. U minus 2 cannot equal 0. U cannot equal 2. However, none of these are the same as what I got, so x equaling, or U equaling 5 can be my answer. Okay, I want you to take a second and read this problem to yourself. I'm not going to read out loud. If you're taking a second to read this to yourself. Basically, with this problem, what I need to do is I need to find the rate total is the rate of pipe 1 plus the rate of pipe 2. And then I want to do all my liters divided by my total rate that the water's emptying. So let's find the rate of pipe 1 first. So I have that much water, it can empty in 225 minutes. So it gets me 2,400 liters per minute. My second pipe, if the same pool is filled with that amount, it takes 150 minutes. So when I add these two rates together, I get a total of 6,000 liters per minute. So how long it fully takes is, if I use both pipes, is this would get me 90 minutes. Okay, the last one we're going to talk about, just because you may see problems like this, it wants us to solve for G. So this is different because we have a bunch of variables around it, when what we actually want is g in terms of other variables. So I'm trying to get that g by itself. I'd still do what I'd normally do, where I need to get everything a least common denominator. So I'm going to multiply this side by g over g. And I can cross off. Sure, my e is the same. And then I'm just isolating my g. So if you see these types of problems on your homework, this is how we do those types. Okay, this is all for this skill. Good job.